Today we're going to learn how to use the law of cosines, but first let's start with a little review of the law of sines. So the law of sines, I've got a side, opposite, and angle, so I'm going to use f over sine 48 equals another side over its opposite angle, 11.3 over sine 67. Okay, so if I want to get f by itself, I just have to take this and multiply it to the other side. So I've got 11.3 times sine of 48 divided by sine 67. Okay, so I get 9.12. Okay, so there's my value of f. Okay, now for this next one, I've got m over sine 135, and then I've got 103, but I don't have its opposite angle. I've got 152, and I don't have its opposite angle. So this one, I actually can't do with law of sines. So I'm not going to be able to solve this one using law of sines. So this is a case where the law of cosines might come in handy. All right, so when you have side, angle, side, which is what we had up here, side, angle, side, or if you have side, 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 you can solve that triangle using the law of cosines. A squared equals b squared plus c squared minus 2bc cosine a. So that's the general form. Okay? It can also be used to find b or c. So it could be b squared equals a squared plus c squared minus 2, and then these two, a and c, cosine of angle b, or c squared equals a squared plus b squared minus 2ab, cosine c. Okay? So the known angle, in order to do this, if you know an angle, like side, angle, side, must be between the two known sides, or it must be the included angle. Okay, so side A and cosine A must be on opposite sides. So it starts with A, side A ends with angle A, or starts and ends with side A and angle, or side B and angle B, or starts and ends with side C and angle C. And what we can solve for is either of the bookends, or what's on the outside. Okay, so we can solve for either the side or the angle that's on the end. All right, so let's try actually using the law of cosines. So we've got triangle FGH. Given angle F is 62 degrees, side G is 14.83 feet, and side H is 9.14 feet. So we have side, angle, side. The angle is between the two sides, so law of cosines will work, and we're looking for the missing side, F. Okay? So we don't even have A, B, and C, but I know that F, side F, and angle F have to be first and last so that I can solve for side F. I can only solve for the very first or the very last item. So I'm going to do F squared equals, okay, then G squared and H squared is 14.83 squared plus 9.14 squared minus 2 times the product of these same two numbers, 14.83 times 9.14 times cosine of angle F, which is 62 degrees. Okay? It's kind of a long string of numbers, but I can actually solve this in just one step by taking a square root. Normally when you take a square root in an equation, you're going to get a plus or minus. but we're talking about a length of a side of a triangle. So the negative square root does not even make sense for this. So it's just going to be the positive square root. Okay, so the square root and the squared here cancel. And so I'm just going to type this square root in my calculator. So that's square root of 14.83 squared plus 9.14 squared minus 2 times 14.83 times 9.14 times cosine 62. And I get 13.27, so side F is 13.27 feet. Okay, so we'll try another one. Triangle NMP, where P is 133 degrees, clearly not drawn to scale. N is 124 feet. So across from N, we've got 124 feet. And side M is 187 feet. Find the missing side P. So we've got side P squared equals the other two sides squared, 124 squared plus 187 squared, minus 2 times the product of those sides, 124 times 187 times cosine of angle P, 133 degrees. And again, to get that squared gone, I just need to do the square root of both sides. So it's the square root of 124 squared plus 187 squared minus 2 times 124 times 187 times cosine 133. So we get 286.31, and again it's in feet. So side P is 286.31 feet. Okay, so that's how you use the law of cosines to find a missing side. So now we're going to try to use the law of cosines to find a missing angle. So before we were given side, angle, side. This time we're going to be given side, side, side. So triangle X, Y, Z, where X is 3, Y is 7, Z is 9. Find the largest angle. Okay, so something we know about triangles, the largest angle is opposite the longest side. So 9 is my longest side, which means Z is my largest angle, so that's the one I'm looking for. Okay, so we'll start with 9 squared equals 3 squared plus 7 squared minus 2 times 3 times 7 cosine, and Z, this is my variable, so cosine Z. Okay, so we're going to do some simplifying and then we'll solve. 9 squared is 81. 3 squared is 9, 7 squared is 49, so if I combine these, I'm going to get 58. And then I can multiply 2 times 3 times 7, so 2 times 3 is 6, times 7 is 42, cosine Z. Okay, so now let's subtract that 58. So 81 minus 58, and that is 23. And then I've got negative 42 cosine Z. Okay, now I can divide by negative 42, so 23 over negative 42 equals cosine Z. Okay, and for my last step to get Z by itself, I can get rid of this cosine by doing its inverse on the opposite side. So if I do arc cosine on the left side, that cancels cosine from the right. So in my calculator, I'm typing second cosine 23 divided by negative 42. And I get an angle measure of 123.20 degrees. So Z is 123.20 degrees. Okay, we'll try another one. Triangle CDE, where C is 2 inches, D is 3 inches, and E is 4 inches. This time find the smallest angle. So that's going to be across from the shortest side of 2. So this time I'm looking for the measure of angle C. So I have to start with that shortest side. 2 squared equals 3 squared plus 4 squared minus 2 times 3 times 4. Okay, so 3 and 4 go here as well. Cosine angle C. So 2 squared is 4. 3 squared is 9. 4 squared is 16. So if I put those two together, I get 25. 2 times 3 times 4. 2 times 3 is 6. Times 4 is 24. I can subtract that 25. So I've got 4 minus 25. That's negative 21. Equals negative 24 cosine C. You might find some shortcuts along the way, and that's okay. I can divide both sides by negative 24, so I've got negative 21 over negative 24 equals cosine C. And I can cancel out those negatives, so I've just got 21 over 24. And to get rid of that cosine, I can do its inverse, arc cosine, on the left side. So I can put in second cosine, 21 divided by 24. And if you never did cancel out those negatives, and you just type in negative 21 over negative 24, that's okay. The calculator knows that's exactly the same thing. So I get 28.96 degrees for angle C. All right, a condition to watch out for when you are given side, side, side. A triangle with sides of 3, 7, and 11. That's not even going to make a triangle. Because if I take the two shorter sides, 3 and 7, is that going to give me something greater than 11? Well, 3 plus 7 is 10. That is not greater than 11. Okay, so I would never actually even be able to get these 3 side lengths to close as a triangle. The longest side must be smaller or less than the sum of the other 2 sides. And if it's not, then the 3 sides will never be able to close and form a triangle.
So now we'll end this lesson with one more practice problem. So we have triangle ABC, in which angle A is 58 degrees, side A is 26, and side B is 29. Okay, now we do not have side, 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 or side angle side, so we can't use the law of cosines. So our only option here is the law of sines. And we only want to use law of sines for angles when it is our only option. Without side, 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 or side angle side, law of sines is our only option. So we have to compare opposite to adjacent to find the number of possible solutions. So opposite of 58 degrees is 26, and the adjacent side is 29. Opposite is less than adjacent, which means more possible solutions. So there are 2 possible solutions. So we had angle A is 58 degrees, side A is 26, and side B is 29. So we will fill out 2 solution sets. Okay, so we have angle B as the first thing that we can find here. So 29 over sine B is equal to 26 over sine 58. Okay, so we have 26 sine B equals 29 sine 58. And we divide by 26. And then we do inverse. So B is arcsine 29 sine 58 over 26. So we get 71 point, and it says nearest tenth, so 71.1 degrees. Okay, now just in case I need to use that for any further calculations, I'm going to keep 3 decimal places, 71.067 degrees. Okay, now I'm going to use that over here and find its supplement, so 180 minus 71.067. And I get 108.933 degrees, so that is the other possibility for angle B, so 108.9 degrees. Okay, so then we can find angle C by doing 180 minus the 2 angles that I now know, 58 and 71.067. So I get 50.933 degrees. So we'll call that 50.9 as we round to the nearest tenth. Okay, then over here I can do angle C by doing 180 minus 58 minus 108.933. So we have 13.067 degrees, so that will be 13.1 degrees as I round to the nearest tenth. And then last we will find the missing side length, side C. So C is to sine 50.933. Okay, so I'm using extra decimal places here so I can be more accurate. And then I'll use 26 and 58 rather than using this pair here that has a rounded number. So 26 over sine 58. So I multiply this across. So that's 26 times sine 50.933 divided by sine 58. And we get 23.8. Okay, then our other option for angle C. C is to sine 13.067 as 26 is to sine 58. And we multiply across. So we have 26 times sine 13.067 divided by sine 58. And we have 6.9.